linking or binding. Then next is loading, then execution. Then comes one more independent thing, that is debugging, or it's a mix of that. So what is debugging? We'll see that. All these steps we'll understand one by one. Do you know anything about compile time and runtime? Static, dynamic. Have you heard of this? Many things you say, this happens compile time, this happens compile time, or runtime. Okay? So runtime means dynamic. Compile time means static, right? So which is runtime here? If you see 5 steps, execution. So this is runtime. This is runtime of your program. And this is dynamic. This is dynamic. Runtime or dynamic? Only that part is runtime or dynamic. Then what these phases are, stages are, these are static. These are static. This is a dynamic. All these 4 stages are static. What does it mean by static and dynamic? Analogy? Any real world example? You already fixed. Okay. Suppose you are planning for a trip. Okay, you are planning for a one-day trip. In the morning you are going to start, evening you are going to return. You are visiting some place. So you have planned who will be going, in which car you will be going, what you will be carrying, food items and other things and all. What all you are going to carry, that's all decided. Then tomorrow morning you are going to start at 10 o'clock. At 10 o'clock you started. All right. Before that, what all you have done is static. And your journey started. Your journey started. It is execution. You have planned, already planned, 1 day, 2 day before you planned, and then you started executing it. Now you are started on the road now, so you are under execution. Okay. Now just one example in this. Carrying water. We will carry this cooler with us, water cooler with us, static. No, whenever we feel thirsty, we stop and take water, dynamic. Acha, cooler water is finished. Then we will stop and take it anywhere, dynamic. Partially static, partially dynamic. So in this way, whatever the things that are happening and being decided on the go, then it is dynamic. Beforehand, whatever is planned and you made all the arrangements, that is static. Okay? So these are static and this is dynamic. Now listen, if you have heard anything like this, compile time, runtime, compile time, runtime, you have seen this. So this is runtime. And all these are compile time actually. But actually compile is second step. But all those 4 steps, in simple words, people use the term compile time for them. It's not compile time everything. Editing time, compile time, linking time, loading time. There are different times. But why to specify separately? Just we say it's compile time. Or whether instead of that, instead of saying compile time, it's better to say static. Static. Static it may happen anywhere time. Okay, got this clear thing? Now, so you have this idea now. So what we have learned so far, we have seen what are the stages of writing and executing the program. Then we have seen, we have categorized them, and something is static and something is dynamic. Now let us start. Editing first. What is editing? Typing a program. Typing a program is nothing but a text. So you can type a program in any text editor. You can use Notepad or MS Word or any text editor, and you can save it as with extension .c or .java or .py for any programming language. You can do that. But usually we will have some IDEs where you can write on the program and you can get the color codes also, so you can easily identify what are the keywords and what are the variables and semicolon is given or not. So IDEs will help you in writing the code, and proper indentation, everything is done. And for rest of the phases, everything is there built in inside the IDE, so that you can say compile, run, debug, there only you can do. Otherwise, in Notepad, you can type the program, save it, and separately you can do it on command prompt. Followed? I was a little bit quick on this one. So you can do it there also. But IDEs are nothing but the text editor only, but they give you the environment where you can write on the program, and there itself you can execute it within their context and check them. So that are IDEs. Okay. Now when you type the program, okay, that is called as editing. Now one thing, when do you decide variable name? Compile time, runtime, variable name. Exactly. Editing time you'll decide. It's not compile time. But if you ask, before explaining this, if I have asked you, you will say compile time. But actually it's editing time. So it's not also editing time. There is one more step beside this. Simply you will start typing the program, open the editor and type the program, or do some homework. That homework also you do. That homework is nothing but a designing of a program. That designing is one more phase. I have not mentioned it here. Designing is also one more phase. So actually variable name you will decide at design time. Design time. Okay, variable name you will decide at design time. But we open the editor for short programs, we open and there write. So designing and editing goes hand in hand together. Okay, next. Now, let me write down one program, then show you what happens in all these steps. Okay, I'll write down one program. So I can erase it like this. Okay. Sure. I'll write on one program. Integer add int a, int b, int c, c assign a plus b, return c. Int main or void main, I'll just say main. Okay, I'll say main, just say main. Here, integer x comma y comma z. X assign 10, y assign 5, z assign add x comma y. I am just saying print here for z. I'm not writing complete syntax of C language. Printf, percentile d, all those things I have not written, just print z. The simple program I have written. Okay, I have written main function, add function. Over, finished. Now what this program is doing, if you see the code from the main function, this is having three variables. One is initialized to 10, second one is initialized to 5, and adding of the add function is called. So this will take what A will get, X, what's the value? 10, and this will get 5, then added and stored in C, and the C 15 is returned, 15 is copied in Z, 15 is printed. Okay, I have written this program. I will compile the program. Compile with the program. So when I compile it, okay, let us call this as first.c program. Oh, first.c program. Let us call this as. Now when I compile, I get a different file. What is that? I may be getting first.obj, I get, if you know that. And after that, finally, you can also make it as executable file. You can make it as executable. So let us say it is exe. We have created the exe. Okay, exe. Now my question is, what does compiler do? It will, compiler will do what? Convert this into machine. Actually, compiler do two things. First, it will check syntactically everything is perfect or not. Everything is perfect or not, making sense or not. As per rules, syntactic rules, you have written the code or not. If it is perfect, then it will convert that everything into machine code. So it does two things. Checking for the correctness of the program, right? then after that it will convert into machine code. So it will convert into machine code. So now my question is coming. I'm sure most of you will give wrong answer. I'm asking a question. Okay. So I have written this program and it's getting compiled and it's going to get converted to machine code. So machine code looks like this: main, and this is the machine code of main, each line. So for every line, exactly one line of machine code will not be written. Multiple lines will be written for that. Okay. So, and in that add function is also called. So this is the machine code for add. This is the machine code for add. Then the remaining code for main, that is printf or something is there. Add function, then main function. Now question is, the machine code that is generated will be like this or like this. First one I'll show you. Main function, this is the machine code, and here add we are calling, so the machine code of add, then the remaining machine code of main. And here add machine code is separate, main machine code is separate. So how the machine code is generated, the first one or the second one? First one. What I told you all. Now, some of you heard first one and then said, no, it could be second one, because already told, na? Most of you will give wrong answer. So which one? First one, second one? First one? No, I am not. Assume that this is their part of main only. Okay, header file, if you include, then discussion becomes little lengthy. You will get the idea how header file works also. No problem. First one. Okay. First method or second method? Second. Second method. As per execution, you are going. You are thinking in the execution way. Yes. But actually, your program, you have kept it in two pieces. This piece separate, this piece separate. All right. Like he's talking about header file. So printf, we have not written printf. It's built in. So its machine code is also kept in this file. Along with add, then main, here printf will also there. Printf is also there. So it will include the function, machine code of that function from the header file or library into your exe file. That is included. That is included. So have you heard that don't include too many header files? Anybody suggested you this one? Don't include too many header files. Include only those which are useful for you. Have you heard this? So what happens if you include too many? Unnecessary. Whatever the header files you include, every function from that header file will be copied in your program actually. Your add function, your main function, all the header file functions also will be copied. So only use those, include those which you are really using. So for us, we have used printf, so I am showing only printf. But printf is there, scanf is there, getch is there, putch is there. All those will be copied in this one, in std.h. Okay, anyway, so let us limit our discussion to this. So actually we think that the first one, but not the first one, second one. It will generate machine code separately for both the function. So this is the important point. This is the important point to understand rest of the things, how they happen in the memory, because data structure is nothing but related to memory only. This is one thing. You can clearly take this one. So we have finished the second step. Editing we finished. Compiling, in that what was important, we have seen that. Now, इसका zooming होता नहीं? Okay. Next. You have guessed this one. Thinking that wherever you have written add, you need the machine code of add function there. So same way, maybe here add is written here. Add may be written here, right? This is the line for add. So machine code should be there. So actually machine code is not copied there. But the address of this function is copied here. The address of that function is copied here. All right. So this address, whatever the address is, so that address is copied here. So same way, when you're calling printf function here, so printf function, instead of printf function, what is written here? The address of that printf function is copied here. Address of the printf function is copied here. All right. So in textbooks, when you read the textbooks, you are reading some passage, and in the passage, there is some special term. What is this term? So for that, you have to refer so and so page. Go there, you will find the complete definition of this term. Right? It's a reference. So same way, a reference is kept here. Reference is kept here. So compilation is done, machine code is written, separate pieces of machine code, and the references are given. So these references are called as what? Meaning, exactly, linking or binding. That is called as linking or binding. So this we have finished. So these references are written. So add means there is that function. Go there and execute and come back. So in their book also, if you see this term, you will go back to go to that page, read that thing, and come back again and continue reading. So the same way execution works. All right. So reference is given. So that references are called as linking. All right. So how that references are written and all, it's a separate subject if you want to study it. How really the reference is written, this is separate. Relative addresses or logical addresses are written there, physical addresses are not written. Anyway, in the next step, you will get a little bit idea. Over, this is over. Can I select this? Okay. Oh. हाँ अच्छा इरेज ठीक है. I kept it small there. Okay. Now, next thing. We have to talk about loading. Okay. Loading. So for that, we have to understand memory. That is random access memory, RAM. Okay. Memory means a device which can hold data, information. But RAM is the technology used for holding that data. The technology used in memory is called as RAM, random access memory. Random access memory means what? Randomly you can access the memory. Randomly you can access the memory. So how that random access memory looks like, we should understand that first. Okay, when you declare a variable, when you create an array, when you create a linked list, everything happens inside the memory only. So you should understand the memory, then only you can understand everything further. Okay, so let us talk about the memory. So usually we draw the memory like this as a block, isn't it? We draw it like this. So you should draw it perfectly. Okay. So assume that this is how we draw the memory, and these are all boxes. Let me finish, then you copy it. Let me finish. Okay. These are all boxes. Okay. What this each box is? Memory location. What is the size of that? 1 byte. 1 byte. So each cell is 1 byte, and it is called as memory location. When do you use a word location? You use a word location if there is an address for it. So it means you are saying every box or every cell is a memory location, means it is having its own address. Yes. So let me give the addresses. So this is address 0, this is address 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8. Next I start from here. What is this address? 9, 10, 11, 12, 13, 14, 15, 16, 17. I have drawn a two-dimensional. So is the memory two-dimensional? No. But if you see the addresses, I have given them linear. 1, 2, 3, 4, 5, 6, 7, and 9. It goes linear. So actually the memory is not two-dimensional. Memory is linear, one-dimensional, one-dimensional. But to understand it, to represent it, we draw a box-like thing. Actually, it's a strip of memory, right? So these are all linear. So every location is having a single number address, not two numbers address. X, Y coordinates are not there. Just one number address is there. So if you say this memory of size 64 kilobytes, 64 kilobytes, assume that the memory is of size 64 kilobytes. See, when you study any subject, you try to take a typical size, okay, and then you will talk about, you discuss everything within that size. Like when you talk about operating system, the page size is 512 bytes, isn't it? Like that we fix the size. So we will fix the size here as 64 kilobytes. So 64 kilobytes means how much? 64 into 1024. Kilo means 1024 here. So 64 into 1024 is nothing but 65536 total. If you see the ranges, 65536. If you see the range, it starts from 0 to 65535. So if you have started address 0 onwards from here, then what is this last address? 65535. Last address is 65535. Understood this one? So memory is, we assume that 64 kilobytes of memory is their RAM size. Now we have in GBs, right? But in the early stage, in the beginning of the machine, means computers, the size of the RAM was 64 kilobytes. 64 kilobytes. All right, 65545. If you want to represent or store an integer number 65535, how many bits you require? How many bits? Not 32 bits. Positive. Everything is positive. This is a different question. Okay. In one byte, 8 bits, right? 1, 2, 3, 4, 5, 6, 7. 8 bits. 8 bits. What is the largest number that you can store? Smallest number is 0. What is the largest number that you can store? 255. 255 in one byte. So if you have 2 bytes, total 16 bits, what is the maximum number that you can store in this one? 2 power 16 minus 1. So how much is 2 power 16? 6 minus 1. 2 power 16 is 655. 36 minus 1 is 35. 64 kilo. It is 64 kilo. All right. So see, this is a different thing. I'm not talking about RAM. I'm talking about another thing. In one byte, what is the maximum integer that you can store if you are storing everything positive? So maximum is 255. If you take 2 bytes together, total 16 bits, what is the largest number that you can store? 65535. Okay. So there is a relation between this one. Later on, we will see this. We are building a framework. All right. So 264 kilobyte means in terms of 2, how much it is? Okay, this is 2 power how much? 2 power 6. And 1024 is how much? 2 power 10. How much it is? Finished. 2 power 16. So in 2 power 16, this is 2 power 16 only. All right. Now back to our discussion. Starting address 0. If a pointer, if you know about this one, definitely everybody knows, pointer assign null. Null means value, nothing, but actually some values there. Not unknown. In C programming, null means 0, 0, 0, 0, 0. Null means 0 actually. Instead of null, you can also assign 0 there. So to a pointer which store addresses, If you are giving 0 means where it is pointing. So this location is kept as parking point for all the pointers. If you say any pointer has 0 means you don't disturb, go and stand there at 0. Okay. If it is pointing somewhere, it can access it. So no, we don't want you to work. Don't be active. Just go and park there, park yourself there. If you need anything, we'll assign an address, then you come and work on it. All right. So this 0 acts as a parking address for the pointers. So this 0 is reserved as a parking location. All right. Now, all right. Now, next point. This is your RAM. This is your RAM. When you start your computer system boots. So booting means what? Loading operating system, which is there on the hard disk. So from hard disk, it will bring it into RAM. So it means the beginning locations that are occupied by operating system in the RAM. Operating system is loaded in the RAM. We are talking about this one only, right? So to come to this point, I have explained all these things. Now you are ready to talk everything about loading, right? So we are talking about program actually, but in meanwhile, we have seen that operating system is loaded in the RAM, right? Now, next thing, I have to take a different picture. I need to keep everything here. That's why I'm just minimizing it. Okay, so that I can keep all the points here and discuss about them. Sure. Okay, I don't need this one. I'll remove this. See, when you have written this program, you will save it on the hard disk. You will save it on the hard disk. Back to this. So you have written actually C program. So first dot C is this file. Okay, this is first dot C. And also what is created? First dot exe. This is another file. Do you agree with this? You will save .c program stored on the hard disk in some folder somewhere, but on the hard disk. Then when you compiled, exe file is created. That is also on the hard disk. So both the files are on the hard disk. Okay. Hard disk is like a shelf. Hard disk is like a shelf. Now you want to run the program, first.exe, you want to run it. Then where it should be for execution? On the hard disk only or on the RAM? RAM. It should be in RAM. Okay. So when you want to read a book, it is in the almara or shelf. Now you want to read it, it should be on your desktop. Then only you can read it. Then only you can process it. So your CPU can process if the program is kept in the RAM, right? Not in the hard disk, it should be brought into the RAM. Now this should be loaded into RAM. So bringing the program inside the main memory, this process is called as what? Loading. This process is called as loading. All right. Bringing the program, executable code of a program from the hard disk, from the file to RAM is called as loading. So loading is a general term, you know. But related to programming, loading that program in the RAM, in bringing it into RAM is also called as loading. Same thing. That's loading. Now everybody familiar with this term loading now, because when you consume media, when it shows that cursor, so it's loading. So here, so unless it is brought into your RAM, it cannot be played. Next. Now the important thing. This machine code is brought into RAM. What is RAM? Collection of bytes. And every byte is having its address. So where it is stored, program is stored in that bytes only. So it means program is also having its address or not. Program is also having the address or not. Yes, program is also having its own address. Program is also having its own address. So let me draw a small picture of this one. Small picture of this one. Okay, let us assume that add function is copied first. Okay, so this is RAM. This is RAM. I'm not showing the boxes, I'm showing the program. Okay, so what is the beginning address of this one? Let us assume that the beginning address of this add function is 100 byte. Just assuming. I am starting 100 because you know operating system is also there. If I say 1, then you will say, sir, where is operating system? So I kept left few for operating system. I am starting from 100 onwards. So what is the address of the first instruction of add function? 100. Okay. Now a little bit more I will tell. Little bit more. Assume that add function machine code is having total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 instructions. 10 instructions. Assume this one. Okay, little bit. We'll discuss about this one first. Then we'll again go back there. Okay. Add function is having total 10 instructions. How much memory it requires to for storing in the RAM? How many bytes it requires? 10 bytes. 10 lines, 10 bytes. So 10 instructions, 10 bytes. But wait, what is the size of the instruction? Have you ever heard of this one? Instruction size is 16-bit, instruction size is 32-bit. Have you heard of this one or not? 16-bit processor takes 2 bytes of instruction. 32-bit processor takes 4 bytes of instruction. So its instruction set is bigger. So instructions set size is there. So it means if you are talking about 16-bit machines, now again we should talk about 16-bit or 32-bit. So we will reserve our discussion within 16-bit. If we go 13-bit, we can take 13-bit also. Okay, but for showing the numbers, talking about numbers become difficult for us. We'll get a bigger numbers. So when you understand about 16-bit, you can obviously understand about 32. So we assume that the instruction size is how much? Instruction size is 2 bytes. 2 bytes. So this is how much? 20 bytes. So this is starting from 100 onward, means first instruction is at 100 onwards, means 100, 100 not 1, first line. 2, 3, second line. 4, 5, third line. You agree with this one? In this way, 10 lines are stored. Back to this. After that, main is also stored here. Main is also stored here. Main. Now, oh, sorry. I should give a space, little bit space here. Main. Okay, main is also stored here. And assume that main is starting from 300. Little away from that, okay? Now, within this one, it is also calling add. Then followed by that, main code is there. Can you visualize this now? Main function, machine code, main function, machine code. Few lines of main, then it is calling add within there also, then after that, remaining part of main. Two pieces separately loaded. Two pieces separately loaded. Now, at the place of add, what should be written? You tell me. Address of add function should be replaced. Yes, address of add function should be replaced here. That is, it should be made as 100. So writing this address is called as binding. This is called as binding. Linking, binding. I said synonym. You can use it as synonym. But binding, you use the term when actual addresses are written. Actual address is written, then you call it as binding. Okay. Now, what all you have understood, you write it. But just one last word, one last one. We understood memory. Okay, let us revise, then you copy it. We understood memory. And I said that every byte in the memory is having its address. And I said that we will fix the size as 64 kilobytes. All right. Then also we learn one more important thing, that is 2 power 16 is 64 kilo. Okay. That was a separate point. Then back. We learned that whenever you want to run the program should be brought into RAM, and that process is called as loading. So when it is loaded in the memory is nothing but collection of bytes where each byte is having address. So the program is also having its address. So then we decided that, let us say the add function is at address 100 and the main function is at address 300. Then add is calling, sorry, main is calling add, means at the place of calling, the actual address of the add function should be written. And that process is called as binding. And the binding has happened after loading. After loading. After loading, binding has happened. All right. So till here, is it static or dynamic? Everything is static. Till here, loading is done, binding is done. All these are static only. All these are static only. Program has not yet executed. So in general, we used to say compile time, but now you can say loading time. You can say linking time. You can say binding time. You can say compiling time. You can say editing time. So you know the differences now. So you can also understand what may be happening at what time. When you come across the concepts, you can understand that. All right. So I have revised the points. Once again, if you want me to revise, I can say that this is RAM, picture of RAM. I have decided that 64 kilobytes and every byte is having its address. It starts from 0 onwards. So that is linear addresses are there and the program should be loaded, brought into the RAM. And let us say these are the addresses and the address of the function call is written. That is called as binding. Okay. So if you want to take notes, you can take it. It's your choice. Taking notes is your choice. All right. I will not dictate anything. At any place, if it's very important, then I'll give you the point. I'll ask you to note down there. For me, I assume that you will remember it for lifelong. Okay? So you'll remember this thing always because the frame you are understanding. So it's no question of forgetting it. Okay? Acha, integer in C language take how many bytes? 2 bytes. When it is decided, okay, let us fix 2 bytes. It depends anyway. Let us say 2 bytes. When it is decided, this is new time again. In this new time is there. Compiler, whoever has designed and written the compiler, it is decided at that time. You say int, it will make 2 bytes. So by default, compiler is doing it. So as he said, depends. So some compiler take 2 bytes, some compiler take 4 bytes. So when it is decided, the person who has written the compiler, team who has developed the compiler, they have decided it. So it's not in our hands. So you can't say compile time, right? 2 bytes or 4 bytes, it's not compile time. It's pre-decided by the compiler. Which compiler you are using, that many bytes it takes. This is over. Now we can switch the screen. Now what is remaining? We have seen editing and we have seen what is compiling. And we came across few important things or misconceptions, whatever there, we have gone into little detail. Okay, we understood the things thoroughly. Now we have to talk about execution. Okay, now this is interesting. Upon this, there are, in the previous gate questions are there upon this point. what we are going to discuss now. And further, means now you are ready with the frame actually now. Framework is ready. Now execution, you can understand how this is happening. So whenever we write a program, you should be able to visualize the execution. Then you can answer the question thoroughly, mainly. Because main thing is if a code is given, you should know what is happening in the code. You should visualize what is happening inside the memory. Okay. See, you visit a doctor, he will hold your nerve and have you taken anything cold? Huh? How he came to know that? So he know the mechanism. He can sense the mechanism. You take a bike to a mechanic, start. Now I'll do it. Go tomorrow, you come, I'll keep it ready. This has gone. So when the program is running, you should know, this is happening inside. So that level of idea you have, right? Then field is yours. Field is yours. You can invent new thing, you can introduce new thing, you can work on the existing thing. If a new thing comes, you can easily understand how it is happening. You will know what is possible, what is not possible. Okay. So out of all these subjects, you have to grasp that idea mainly. So we started with this now. We are ready to understand the rest of the concepts now. Let us move ahead. I'll go to the next page. Now, quickly, I will write down the program. Okay, no need of writing the program. You are already aware of it. So I'll draw this RAM, picture of RAM once again. Oh. Okay, this is RAM, entire RAM. Now, listen. Part of it is occupied by operating system, you leave it. Now, assume that this entire 64 kilobytes of memory is given for a single program. Single program for execution. We have seen it is loaded. We have seen it's loaded. So the entire memory is given to it. It's just like this entire room is given to me for conducting a lecture. So think that I have selected this place for standing here and giving a lecture, and these benches have been already fixed for student to sit here, and some more chairs or empty benches are lying there. So if anybody comes during the class, they can go and sit there. Arrangement is there at any place. If you see the lectures or any session is happening, some fixed arrangement will be there, stage will be there. After that, few extra chairs will be there. So how to use the space is decided, right? So same way, when a complete RAM is given for a program for its execution within the CPU, the program will execute. So the program should come here and execute. So how it will use this RAM? It will divide this RAM into three major sections. It will divide the RAM into three major sections. So the first section is called as, okay, I'll take this color. Okay. This section, it is called as code section. And this I'm calling it as stack. And this I'm calling it as heap. So actually how it happens is, if this is RAM, the code section starts here, code section goes like this, and the stack come like this from the higher addresses downwards, and whatever the space that is remaining after occupying this and this, that is called as heap. Stack starts from the higher addresses downwards, and the code section starts from lower addresses upwards. Okay, in between the space is remaining, that is called as heap. But if you visualize like this, if you see the diagram like this, you can't understand the things working. So I have decided to take this picture. Code section, stack, and heap. So you can understand the behavior, how it's happening. Otherwise, this will be inverted a little bit. It's not easy to understand. Okay? So actual thing I have told you. Now, we'll be following this diagram for understanding everything. Okay? Anyway, three pieces are there. Code section, stack, heap. You keep them anywhere, but really where they happen is different thing. Okay, this is one point. Now one more thing. There is another way of division also here. That is data section, code section, that is also there. Okay, so the same thing, similar thing only, but I'll come to that later on. So right now we follow three sections. As per gate questions, we follow this one. As per the operating system or C program concepts or what I should say, memory related concepts. From the textbooks, you'll find some other words. But for the gate questions, these are the terms used: code section, stack, and heap. All right. Data section word is not there in the gate questions. Okay. That data section comes as a part of code section. I'll tell you that one anyway. So how it uses is like this. Now let us see. Program is loaded. Where the program is loaded? Code section. Program is loaded in the code section. So I will write on the program here. I'll write on the program, add, okay, what it is taking, A and B and C is there. C, okay, int C is there. I will write on the program once again. C assign A plus B, and it is returning C. Now next is main. Main is having A assign 10, B assign 5. Okay, X assign 10, Y. So this is main, X assign 10, Y assign 5, Z assign add, X comma Y, print Z. You are already aware of that, so I'm just scribbling in a small font size. Hope you understand this one, right? Or you want clear lines? You are able to read it, right? Sure. Program machine code of the program is kept in a part of memory. That section is called as, come on, code section. Already you have seen it here. I said that it will be loaded like this. So I have shown you the picture. So I was explaining about binding. So I kept a small picture and I have shown you. Now I'm giving you the clear picture here that actually the entire RAM is divided into 3 sections: code section, stack, and heap. So the code is kept inside the code section. This is called as code section, and even it is also called as text area. It is also called as text area, or text section also you can call it as. Okay. Actually, it's not text machine code, but we call it as text. Are you ready now? Till here understood? Now what about these two? These two. Now I am going to talk about execution. Once again, repeating, once again, editing we finish, compiling we finish, linking we understood, that was logical addresses. That add is here, we should call it. Then loading we understood, keeping it. Then binding we saw. Binding. Acha, one thing, binding was done with the help of, earlier what was done? Linking. Linking was done after the compilation, during compilation you can say. But binding is done for after loading. So do you want to understand just the idea about linking and binding? You want to get the question example? Watch this. We all go together and watch a movie, okay, in Konark Theatre tomorrow afternoon, matinee session, okay? 15 members, 15 tickets will buy together. 15 tickets will buy together. On the 5th seat, I will sit. Seat number 5. So will I get seat number 5 there? What does it mean? Seat number 5, I'll sit there. So what does it mean? In our tickets, I'll be sitting on 5th ticket seat, all right, on that seat. So can I decide right now that what is that seat number? No. So, but I said 5th now. So what is this? Physical seat number or logical? You agree with this? Logical. We'll buy 15 tickets. In that, on the 5th one, I will sit. So logical address, I am telling you. When you go and buy there, you will get in a C row. I don't know what are the rows nowadays. C row, suppose C row. From 19 to some number. We got it. So 19 is the first one. 19, 20, 21, 22, 23. I'll be sitting on C23. That is physical address. Physical address. But beforehand, we decided that was logical. When we already got the ticket, now the show is about to begin. We got loaded in the theater now. We are in the seats. Loaded, right? Movie is about to start. We are loaded now. At the loading time, binding can be done. 5th place, I will sit at 5th place. This is the analogy. Now exactly how that happens. So now this is enough for you. How to play with the numbers in the memory, in the coding part, you can learn it on your own interest. Okay? Is it clear till here? So binding is done after loading. But for binding, something should be done at the compile time only. So that is called as linking. So linking and binding, these are the differences. Back to this. Code section, text area. Now, we are going to see the execution, the most interesting part of this one. Okay? Let us start. Execution. Execution starts. First starts from main. In the main, the first line says that it needs three variables, x, y, z. I have not written here, right? It needs three variables, x, y, z. Execution started. Execution started. And the first line said that I need three variables. 2 bytes for x, 2 bytes for y, 2 bytes for z. Memory is allocated for three variables. Execution started. So can you tell me when the memory is allocated? Compile time or runtime? Runtime. Memory is allocated runtime. Memory is allocated at runtime. It's not compile time. Yes. So memory for the variables will be allocated at runtime only, not compile time. But what is the name? What is the size? How much memory they can store? What will be the initial value? This is all decided at compile time initially, before dynamic. It's not dynamic, it's static. But the memory allocation is dynamic, okay, at runtime. Okay. So this is done inside which section? Stack. Stack. So the piece of memory allocated for the variables that belongs to main section, this piece or this block, like this thing that's a block, we call it as stack frame. And also it is called as activation. Later on you can copy it. Activation record. Just listen, just listen. This piece of memory, actually if you say 2 bytes, 2 bytes, 2 bytes, total 6 bytes. But I have made it as a block to just made the boundaries. Total 6 bytes that belongs to main function, variables of main function. That piece of memory is called as activation record, or also it is called as stack frame. All right. It may not be exactly for the variables only. It may be consuming some extra bytes also. Now, why we don't know? Right now we don't know. Okay. We are concerned about variables. So it will occupy the memory for the variables. So this is called as stack frame of main. When it is created, stack frame or activation record, when it is created, when the program has started execution. Yes, very good point. Now the next line says that store 10 in x. Okay, we have a variable. 5 in y. Yes, we have a variable. Then next line is calling add function. Control goes to add. It's another function. It's another function. It's having its own variables. What are the variables? A, B, C. This is the activation record for add. This is for main. This is for add. This is for main, that is for add. All right. Now, we are on the add function now, execution. We are doing it line by line as if we are CPU. As if we are CPU, we are doing in that way only. So first line, A, B. So actually the values are coming from there. So what is coming from there? This is 10 and this is 5, right? Now next line, C is also there. Okay, C assign A plus B. So these two values are added and this result is 15. So I have executed all the lines here. Now return. So return means this value is this value is copied in Z. So the value 15 is copied here. Right? Now it has went back to main. Na? Return means went back to main. Add is over because the last line was return C. Activation record is deleted. When it was created, when the function was called or executed, called or executed. When the function was called, activation record is created, all the variables were created, values were kept, and the execution was done. Once the function ends, activation record is deleted. So when the variables inside the functions, when they got the memory, when they were created, when it was called, and when they were destroyed, when the function ends. Is it static or dynamic? Dynamic. Runtime it's happening. Dynamic. All right. So just imagine I'm preparing any dish. Okay, I should not go far, I think. I'm preparing any dish here. Okay, in kitchen, I'm preparing something. Now I have to cut onion. So I'll keep this aside. And here I will cut onion and then take that pieces, clear everything, and the result I've used here. Function was called for chopping and cutting, and the function ends. The return result is taken here in the main function in the main dish, and this is cleared. Same way it's happening or not? All right, add. Okay, give the values. What are the values? Okay, we will add, and the result is 15. Finish. Take the result. Over. Chopping and cutting was done, and the result is given to you. It's just like that. Okay. So what we learn in this one is that memory for the variable is allocated at the execution time, but whenever the function is called. So activation record is created when the function is called. Activation record is destroyed when the function ends. And this all happens inside RAM, inside the main memory. All right. Now after that, it is printing the result Z, and after that, main also ends. So this activation record is also deleted. This is also deleted. This is the mechanism you should clearly understand to understand all the concepts of C programming and all the concepts of data structures and algorithms also. All right. Whenever you see, you should visualize this, what is happening inside. Then you can answer everything. You can understand what is happening inside. Now you know all the nerves, how the nerves are working. I have not gone to the hardware level. If you can relate it to a hardware level when you are learning CO or other subjects, you can do it there. Whatever you learn here, you can relate it there. Okay? So now you can hold the nerve and tell what is happening. All right? So this is about the code section, and this is about the stack. And we learned that stack frames are created and destroyed. All right? Now, I think we should stop here. Right? Or shall I continue till 9 o'clock? What was the time? Actually, Ramzan is going on. So I was fasting. So fasting, and after that, namaz has finished at 7 o'clock. Just 5-10 minutes, that is 6:50. So I came down here after that. So that's why we are scheduling from 7 o'clock. Okay. And just we wanted to start with this subject first. Right. So we will have few sessions. Then after Ramzan will carry on, I think. They will plan and tell you. They will tell you how to do that. So shall I stop? Next, I have to ask questions on this one that are related to get questions again. So shall I ask now only? Or you'll remember it till tomorrow, so I'll ask it tomorrow. So you'll not remember it till tomorrow. you remember it till tomorrow. We'll put this diagram once again. Then we'll see which variable is created where and why this heap is. Okay? We'll learn about all those things. Now you understood what is what. Okay? Some gate questions are there based on this one. So similar to gate questions, I'll put them. So we'll stop here. Sir? Sir? Shall we stop? 8:15 it is.